Okay, this video is about waves and light, and we're first going to talk about a few pieces of terminology regarding waves, and then we're going to talk about light, and eventually we're going to talk about electrons, but for now it's waves. So this picture shows a wave going up and down, and we talk about the distance from one point on the wave to the same point on the next cycle as being the wavelength. And the wavelength is designated by the Greek letter lambda. So I'll write that, lambda. And so that is the distance or length of one cycle. And the units for wavelength, typically for wavelengths of light that we talk about, like visible light, is the nanometer. It can be, of course, any distance, but nanometers are typical, which are obviously 10 to the minus 9th meters. Sometimes we also talk about picometers, 10 to the minus 12 meters. We also talk about angstroms and some other units for wavelength, and any distance can be a wavelength. Another term is the distance or the height of one crest, or identically it would be the height of one trough. And so that is known as the amplitude of the wave. And so that is the height of one crest, which is identical to that of the trough. All right, and another term we need to know related to waves would be the frequency of the wave, which is basically how often the waves go by. Or waves cycle. All right, so we give frequency in the Greek letter nu, which looks sort of like a V, and it is the Greek letter nu. And the units for frequency are typically 1 over seconds. And 1 over second, which can also be written as s to the minus 1, is also known as a hertz. And that's abbreviated Hz. So an inverse second is a hertz. And sometimes people also use the term cycles per second for hertz. All right, and the speed of light is a known quantity. It is 2.9979 times 10 to the 8th meters per second. That's the speed of light in a vacuum. And it's not much different outside a vacuum in most cases. For this course, we will probably always be able to round that to 3 times 10 to the 8th meters per second. And then an important equation relates the frequency, nu, and the wavelength, and when you multiply those two, you get the speed of light. All right, so given the information we've just had, you now should be able to do a problem where you calculate the frequency of light with a wavelength of 720 nanometers, and we want the answer in megahertz. So I'd like you to try this problem. Try it first, stop the tape now. If you need a hint, then I'll give you a hint after this. Okay, so the hint is that you're going to need to do probably 3 steps. First, you're going to need to convert the wavelength to meters. Then you're going to need to use the speed of light equation, and then you're going to need, which will give you the frequency in hertz, and then you're going to need to convert that to megahertz. All right, so let's work that problem. The wavelength, lambda, is 720 nanometers, which we know is 720 times 10 to the minus 9 meters. It's not scientific notation, but we've converted it to meters. And then we can use the equation C equals nu times lambda So that equals, so we can then solve for nu, which equals c over lambda. And then we can start plugging in our numbers. C is the speed of light, which is always 3 times 10 to the 8th meters per second. And lambda, we now know, is 720 times 10 to the minus 9 meters. Okay, since we have this in meters, and since this is in meters, our answer will be in 1 over seconds. Okay, so do the division on your calculator. There are 3 sig figs. Well, let's say this started with a point. There are 3 sig figs, and so we get 4.17 times 10 to the 14th inverse seconds. And remember that inverse seconds are the same as hertz. So we have 4.17 times 10 to the 14th hertz. We wanted the answer in megahertz. So now we'll simply take that number, 4.17, I'm going to rewrite it because of the space, 4.17 times 10 to the 14th hertz, and we're going to multiply it by the conversion to megahertz to cancel hertz. And that conversion would be that there are 10 to the 6th hertz per 1 megahertz. Remember, you can put this over 1, and then the calculation will give you 4.17 times 10 to the 8th megahertz.